Welcome one, welcome all. How are you guys today? I'm glad to hear it. I hope you guys are well. I hope this does nothing to change that. It is Wednesday, our saddest day of the week this week. We already sorted that out. Let's see. So, goals for today. I wanted to look at the combination case of lenses, and I wanted to talk about the Rayleigh's criterion for being able to discern between adjacent objects, and maybe along the way we'll do a couple of examples, and then we will start to pack in our discussion of optics. So, combination of paraffin lenses. In this case, what we do is we use the image from the first lens as the object for the second lens. And in that case, well, we'll do this in example fashion in a second, but let's also add in a special case where the two thin lenses sit back to back. So if the two thin lenses have focal lengths f1 and f2 respectively, then just call P1P the object distance for the pair. We can say that 1 over P is equal to 1 over P plus 1 over Q1 is equal to 1 over F1. And then we can also say that P2 is minus Q1. So 1 over P2 plus 1 over Q2 is equal to 1 over F2. And so minus 1 over Q1 plus 1 over Q2 is equal to 1 over F2. Call that equation 2. Adding equations 1 and 2, we can say that one over P, the 1 over Q1 minus 1 over Q1 cancel, we get that 1 over P plus 1 over Q2 is equal to 1 over F1 plus 1 over F2. Yay?
Can you draw what back to back means in this case?
Although technically, what I'm really saying is that the centers of the lenses are basically touching. Is that all right?
So that's the equation for this scenario right here.
For this special case, yeah. And we can say that that is 1 over some new equivalent focal length, 1 over F equivalent, where 1 over F equivalent is 1 over F1 plus 1 over F2.
So in here, Q1 and Q2 are just like before, the distance to the image.
Q1 is the location of the image produced by the first lens. And Q2 is the location of the image produced by the second lens. P2 is the object position for the second lens.
Are we concerned where the image is produced, given that they are literally on top of each other?
Yes. Yeah, so this allows us to say that 1 over P plus 1 over Q2 is equal to 1 over F equivalent. Work. So there's our two lens, F1, F2. This distance is P, and this distance is Q. Something like that. And I should call that Q2, I guess. Keeping with what I did here. The equivalent focal length of this back-to-back pair of lenses is 1 over F1 plus 1 over F. Sorry, that's not true. So 1 over F equivalent is 1 over F1 plus 1 over F2. I can multiply top and bottom by F2, top and bottom by F1, and I can say that 1 over F equivalent is F1 plus F2 over F1 times F2, or the F equivalent is F1, F2 over F1 plus F2. But again, that's all this special case. Yay? Okay, so let's try an example just to round things out a little. So two thin lenses, converging thin lenses. F1 is 10 centimeters, and F2 is 20 centimeters. Separated by 20 centimeters. we place an object 30 centimeters to the left of L1. We want to find the position and magnification of the resulting image. So, flatter than that, but oh well. Bless you. So, that's 10. The object is placed 30 centimeters. I don't know if I left myself enough space for this. To the left of L1. Yay? Okay. So, same deal as always. I guess before I try this mathematically, I'm just going to ray trace it so I have some sense as to what I'm expecting. I'm going to get some image like that for the, I guess I could call this I1. Okay? We're going to use I1 as the object for lens 2. So I'm going to just let this ray continue. What is a ray that comes in parallel to?
You go to the focal point.
You go through the focal point. If I put the object nearer to the lens than the focal point on the front side, what kind of image am I expecting ultimately? I'm expecting it to be virtual on this side, right?
Oh yeah, because it's between focal point and the...
But let's... Oh, drats. So all proud of my artistry. No, not so much. Okay. So now let's try this mathematically and see if we get something that stands to reason. So ultimately, I'm expecting that the object is going to produce an image that's somewhere between these two, and looks something in that family. I don't know. I don't know how well we can trust my drawing, but looks magnified. Do you guys have any concerns about the way I chose the rays?
Yes.
Okay, so do you want me to go through how I chose them?
I just don't understand the one that's going, the one that started going parallel to the axis.
This one.
Yeah, and then went down, and then you're saying it bounces.
No, I just stopped using that one. It would travel through this ray, or it would look through this lens, but since it's not coming paraxially, it's not coming through the focal point for lens 2, it's gonna, I don't know, bend off like that. Actually, I can tell you exactly what it's gonna do. I'm cheating, but let me use a different color so that. So it would continue like this, and at least according to my drawing. It would come out like that.
So the traced one,
But I wouldn't have known this until after I already knew where the image was, so I just skipped that one.
but the dotted one through the middle of the other one is just,
Yeah, if it passes through the center, it doesn't refract. So I knew that this one that was coming in horizontally needed to pass through the focal point over here, so I could back trace that to here. And then I just needed one more to find. And so what I chose was, let's just choose this guy, which I know is going to follow a straight line and back trace so that they meet here. Are you guys happy with how I chose rays? Does that make sense? I think that I've convinced Chris, but have I convinced others?
Can you say again why the
I
final
haven't even
image
convinced Chris. Chris wants to cut my brake lines.
Can you say again why the final image didn't come out on the other side?
Sure. If I just gave you a converging lens with a focal point here and say here, for symmetric curved lens, front and back convex, and I put an object here. If I take a ray that comes in parallel to the axis, how is it gonna
Go through
come through
the
this guy,
focal
right?
point.
If I pick a ray that wants to pass straight through the center, doesn't refract. If I pick a ray that wants to come from here, oh, that's pretty crappy, but the image is somewhere there. Modulo my ability to draw straight lines. If you put the object closer to the converging lens than its focal point, then you're going to get a virtual image. So here, the object for lens 2 is the image from lens 1, but the image from lens 1 is right here, but the focal point for lens 2 is right here. And so it's going to cast a... You guys are okay with this?
So the orange is the final image, right? That's the final product.
This guy is the ultimate. Yeah. Okay, so let's try this with a little bit more math built into it then. So we have that 1 over F1 is equal to 1 over P1 plus 1 over Q1. And so I can say that 1 over Q1 is 1 over F1 minus 1 over P1. Yay? And so I can say that multiply top and bottom by P1, multiply top and bottom by F1. That this is equal to P1 minus F1 over P1 F1. And so I can flip. Q1 is P1 F1 over P1 minus F1. P1 was 30, is that right? Yeah. 30 centimeters. F1 was 10 centimeters. And then 30 centimeters minus 10 centimeters. So 300 over 20 is 30 over
15.
Thank you. 30 over 2. Sorry, my OCD wouldn't let me not finish. Yay?
Yeah.
So what's this distance? 20. And so the original I1, 15 centimeters, you can see what a lovely, incredibly accurate sketch I drew. Right, this is clearly 1/4 of this distance. Yeah? So, what is the expression for that? Gaslighting? So, if you go to San Diego, there is an entire gaslight district. I didn't realize this was a bad thing until I, who knew? Now what? Well, the image from 1 is the object for 2. So what is the object distance for, oh yeah. What is the object distance for lens 2? P2 is equal to what?
5.
5 centimeters. And so we can say that 1 over P2 plus 1 over Q2 is 1 over F2. So again, 1 over Q2 is 1 over F2 minus 1 over P2. That looks suspiciously like what we had here, and we said that that wound up being something like P2 minus F2 over P2 F2. Or that Q2 is equal to P2 F2 over P2 minus F2. P2 we just said was 5 centimeters times F2, what was F2, 20?
Shouldn't Q for Q1 be negative 15?
No, it's on the real side.
You're using the PHYS centimeters at the object, right?
Yes, yeah. So P2 is 5 centimeters because it's the image for lens 1 is the object for lens 2. Hooray?
Yeah.
Okay. Over P2 is 5 centimeters minus F2 is 20 centimeters. 100 over minus 15, is that 6 and change? Minus 6 and change? 6 and a third? What is
6 2/3.
6 and 2/3? I yield. So now we want to find the first magnification, then we want to find the second magnification. So how do we find M1? M for the first lens. Minus Q over P, minus Q1 over P1. So minus 15 centimeters over plus 30 centimeters. It was 30, right? It's minus half. What does the minus tell me?
Inverted.
Inverted. What does the half tell me?
Half the size.
That this is half as big as this, which clearly is true. Again, I did just a bang-up job with that. I tried really hard. I don't know. Can't win. How do I find the second magnification?
Q2 over P2?
Minus Q2 over P2. So that was, I think you just told me minus 6.67 or minus 6.666. Oh, minus minus is plus over 5 centimeters. So let's see, that's, oh, come on, Mark, that's not hard.
Kind of hard.
1.3.
Great.
4.
Yeah.
I passed my algebra test.
So if I want the overall magnification, it's just M1, M2 product. So that's 4/3 divided by 2 is 4, 6 is 2/3 negative. Yay. They all have Kaplan Bractor, at least thus far. Day's young. Day's not young, I've been up since 4 a.m. Is it nap time yet? Let's see. Questions, comments, concerns?
This will be on the exam tomorrow, right?
Combo lenses for sure, yeah. Yeah, that's why I started doing problems like that last week in problem session. Other questions?
How would that change if instead of having 2 divergent lenses, we have 1 and 1?
Say this one more time, I apologize.
How will the final image be affected, differ from what we have right now, if the second lens were divergent, because we had 2 convergent lenses?
It'll still depend on the focal lengths. There's no real shortcut for drawing the, we can try one really quick. We want to keep everything the same, just flip the,
Right, just second one, instead of being divergent, we
let's see.
convergent, we got a divergent lens.
Let's see, I think I can get that done without setting us back too much. Since clearly it doesn't matter how hard I try, is it okay if I just stick figure this? Oh, but that is far too far, because otherwise it won't be able to fit this on. Okay, so this one was 10 centimeters. And so then F2 is going to be what? Minus 20? Thank you kindly. And so we want to be fancy. As long as I can't get this right no matter how hard I try. So half that is probably there. And then this one has a focal point here. Here. So I'm going to make this one biconvex but symmetric, focal length 10 centimeters. I'm going to make this one biconcave but symmetric with a focal length of minus 20 centimeters. Miguel.
Why is it negative 20?
So remember the veiled, I don't want to call it a threat because I'm not actually being recorded because the camera's pointing in the wrong direction.
Oh, I missed it.
So we redo it again?
Well, I think that you've been watching this or listening to this. Now
You're watching the wall.
you can see what the question was.
Not reliable about the technology.
I am an unreliable narrator.
No one is perfect, Professor.
Okay, so if you've been listening along at home, first of all, why? The worst part of this is my monotone. Just barely above that is my artistry, but this is the problem that we talked about without actually showing. Apologies. This was the stuff at the beginning. I don't know what to do about that. Sincere apologies, I guess is what I can do about that. And could you register the sincerity in my voice?
No.
No.
Monotone, so. All right, good gracious. Well, watch this one, because actually, yeah, half an hour of just listening to my dull droning monotone. Patience of a saint, if anyone's actually done that. All right, frustrating. What got me on this was Miguel asked, why is the focal length of this one negative, whereas this one was positive? And I said something to the effect of, I don't want to say this because I'm being recorded, and I looked to the camera. But
Is it diverging?
yes.
Okay.
So remember, the veiled threat that I made previously is what you're likely to get on exams is F1 is absolute value 10 centimeters, absolute value of F1 is absolute value 10 centimeters, absolute value of F2 is 20 centimeters. But what I've told you is that they're converging, so you know that they'd be positive. And likely I would do something similar here where I tell you that 1 is converging, 2 is diverging, but I gave you the absolute values of their focal lengths. And then from that you need to remember which one's positive, which one's negative. All right, so we wanted to put this object 30 centimeters away. Cranky with myself right now. Very, very cranky. So, same as what we did there. Let's draw a couple of rays so that we can find our image. Well, this time I have the benefit of knowing where is that image supposed to wind up. supposed to want to 15 centimeters through. So let's see if I can get the image to show up here. This is really, what do they call that, teaching to the test? I know what the answer is, all I have to do is somehow make this work. I suspect that the problem is I can't draw, but hey, it's a miracle. Okay, so there's I1. I cheated like mad here, right? I forced those lines to, I went backwards to make sure that it actually cut there, but oh well. Still proud of myself. All right, so now we have, this is our object. And the so when we have our diverging lens, a ray comes in parallel, what does this one do?
That's gonna do.
Do that. Bless you.
Thank you.
And then we also have okay. And so we get an image like that. So let's try this. So, oh good golly, this is going to be really tiny, isn't it? Okay.
Why you make them bigger than they appears?
All right, let's try. So comes in parallel. This one. Let's do this.
My high school is talking about drawing this out. So I just, after 20 years, I'm still doing this and we're stuck.
Does that not even closely resemble a straight line? It's the thought that counts. And then we can draw one. Really doesn't seem at all. Decent to me, but because that looks really horrible, but okay. I could draw one. That wants to go towards the. Wants to go towards this, but instead comes out straight. Backtrace these. Really did not turn out right. This is really bad artistry.
Oh, I know what you're doing.
I get it that badly. Let's do this mathematically, because my drawing is clearly not going to suffice. So we know that same as what we have over here, Q1 wound up being 15 centimeters. So P2 winds up being what?
Five?
5. And so we can say that 1 over P2 plus 1 over Q2 is 1 over F2. We said that this told us Q2 is going to be P2 F2 over P2 minus F2. Let's see. So 5 centimeters times minus 20 centimeters. Times 5 centimeters plus 20 centimeters. So minus 100 over 25 is minus 4.
Yep.
Maybe that's why my drawing turned out so badly. Because those things really do want to intersect pretty much right where, if that's 5 centimeters, this wants to intersect basically right in front of that, right? And I just didn't draw lines straight enough for that to actually look at all reasonable. Okay, so then we get, I don't know, an image in this case right there. And we can say that, oh, but that's got to be tiny. That's way too big. It's got to be like, it's got to be like that. So in this case, I think we already did this one, but M1 is minus 15 centimeters over 30 centimeters is minus half. And then M2 is minus 4 centimeters over 5 centimeters is 4/5. And so M total winds up being minus 2/5. Horrible drawing.
How, you went, the value for Q2, you went P2 minus F2 to 5 plus 20?
Yeah, because F2 is minus 20, so 5 minus 20 is 5 plus 20.
Oh, that's right, okay.
Better.
In exam, will we have to like draw similarly what you're doing?
If so, I will give you cases that aren't quite this poorly planned. Like that one, I mean, that's doable. This one, because these two are practically on top of each other, that's a mess. So. Questions, comments, concerns? So the short answer to your question is, yes, you're responsible for drawing ray diagrams, even for multiple lenses, but in the case that that shows up, I won't have it so that they're right on top of each other. If they are, something has gone wrong. This one I didn't put any plan to, I just took the number and flipped the second lens. Yay? Okay. Let me talk about X-ray really quickly. Because X-ray diffraction is cool. Let's see, how did I want to sketch this? Yes, this is what I want.